Welcome back to the Deep Dive. Today, we are not just talking about IT. We're talking about survival.
That is a dramatic way to start us off, but honestly.
It's pretty accurate.
We've got a stack of notes here. It's titled AWS Practitioner 202 Overview of Cloud Security. Now, I know what you're thinking.
Oh, yeah.
People see the word security, their eyes just glaze over. They think passwords, firewalls, the person in the basement who says no to everything.
Right.
But reading through this, it's a completely different picture. It's not about building a fortress anymore. It feels more like, I don't know, designing a biological immune system.
That is the perfect analogy. The old model, that was the castle, right?
Yeah.
High walls, a moat, a drawbridge. The bad guys are out, the good guys are in.
And once you're inside, you're trusted.
Implicitly.
Yeah.
But the cloud, it just doesn't work like that. It's porous, it's, everywhere. So the source material here is arguing for this massive philosophical shift from blocking access to intelligent adaptation. And that's our mission today. We are going to decode this absolute alphabet soup of AWS services, KMS, WAF, Shield Inspector.
There are a few of them.
And figure out not just what they are, but why they matter to you. Because looking at the benefits section right at the top of our notes, the first thing that jumped out at me wasn't protection, it was scalability.
Right. And that catches a lot of people off guard.
Exactly. Usually when we talk scalability, we mean my website can handle more traffic.
Correct.
But this is talking about security scalability. What does that actually look like?
Okay, think about that fortress again. If your kingdom doubles in size, you have to build twice as many walls, right? You need twice as many guards.
Takes months.
Months, maybe years. In the cloud, if your traffic spikes from 10 users to 10 million overnight, your security infrastructure, your firewalls, your monitoring it, scales right alongside it, instantly.
So if I suddenly go viral, I don't become more vulnerable just because I'm bigger.
Precisely. In fact, you might even become more secure because you have more data flowing through your monitoring systems.
And that ties directly into this other concept that keeps popping up, the shared responsibility model. I see this everywhere. It kind of sounds like a legal disclaimer to get them off the hook.
I get that, but it's actually a massive cost-saving mechanism. It's huge for the bottom line.
Okay, break that down for me.
In an on-premise data center, the old way, you're responsible for absolutely everything. The physical lock on the door, the air conditioning, the server hardware, the OS.
The undifferentiated heavy lifting.
Exactly. No customer buys your app because you have really good air conditioning in your server room. So with AWS, they take the bottom half of that stack. They handle the security of the cloud, the concrete, the steel, the network cabling.
And I'm just responsible for what I put in it.
Security in the cloud, your data, your patches, your firewall rules. You're offloading this massive operational overhead.
Which explains the compliance bit. The notes mention support for over 143 compliance programs. I mean, the list. IPPA, GDPR, PCI, just goes on and on.
If you had to certify a physical data center for all of those on your own, you'd need a dedicated team just doing paperwork for years. AWS just hands you a chunk of that certification.
You inherit it.
You inherit that security posture.
Okay, so we save money, we save time. That's the business case. But the real meat of this, and where I want to spend our time, is security automation.
Yeah.
The phrase used is detect and respond. It doesn't say prevent.
That's the modern mindset. You have to assume breach.
Right.
Or, more commonly, you assume someone's going to make a mistake. The goal isn't just to stop it, but to catch it and fix it faster than a human could blink.
To catch it, you have to see it. So let's talk about visibility. The eyes of the cloud. The notes list a heavy arsenal of logging tools. And honestly, CloudTrail, CloudWatch, X-Ray, it's easy to get them mixed up.
Yeah, they do sound similar.
Let's distinguish them. First up, this seems like the big one, AWS CloudTrail.
CloudTrail is the ultimate tattletale, in the best way possible. It's your governance and auditing tool.
The notes call it the auditable record. It answers who, what, when.
Precisely. Every time someone makes an API call, and remember, in the cloud, everything is an API call. Logging in, spinning up a server, deleting a database, it's all recorded. If a critical S3 bucket is missing, CloudTrail is where you go.
Okay, so CloudTrail is the detective for the past. Then what's Amazon CloudWatch?
CloudWatch is the monitor for the present. It's operational. It's looking at metrics, CPU usage, latency, error rates. CloudTrail tells you who changed a setting.
And CloudWatch says, and now the server's on fire.
Exactly. They work hand in hand.
Got it. Then we have AWS X-Ray. The name implies seeing through things.
That's exactly what it does, but for distributed applications. You know, with modern microservices, a single click might touch 10 different services. If the app is slow, good luck finding out why.
It's a needle in a haystack.
It is. X-Ray traces that request through the entire chain and highlights the specific component that's causing the bottleneck.
So X-ray is for performance. What about the network itself? The notes mention VPC flow logs.
Think of that as wiretapping your own network. It captures the metadata of the IP traffic. It won't show you the content of an email, but it will show you that some unknown IP address from a weird location just tried to connect to your database port 5,000 times.
A brute force attack.
Right. And finally, in this visibility stack, we have AWS Config. Config is your historian for settings. It records the state of your resources over time. So if your website breaks on Tuesday, you can ask Config, what did this look like on Monday? And see the difference.
Okay, I am seeing a problem here. We have CloudTrail, CloudWatch, X-Ray, flow logs, config. That is a fire hose of data. I'd be drowning in alerts.
You absolutely would be. It's called alert fatigue, and it's a real security risk because you just start ignoring everything. And that is why the notes introduce AWS Security Hub.
The unified view.
The single pane of glass. It ingests the findings from all those tools, and third-party ones too, and it normalizes them. But crucially, it prioritizes them. It tells you, ignore those 50 low-level warnings, look at this one critical thing right now. It turns noise into signal.
That feels absolutely essential. Okay, so we have the eyes, we can see the threat. Now let's talk about the muscles. Active defense. The notes highlight two heavy hitters, AWS Shield and AWS Guard Duty. Let's start with Shield because it deals with, the most common attack out there, DDoS.
Denial of service. Yeah, just flooding a website with junk traffic so real users can't get in.
The notes say there's a free version.
Yes, AWS Shield Standard. It's always on. If you're building on AWS, you're automatically protected against the most common network attacks. You don't even have to configure it. It's just there. It's just part of the plumbing.
That's pretty reassuring. But then there's Shield Advanced, which is a paid service. Why would I pay for it if the standard version works?
So a few reasons. Standard covers the basic network layer. Advanced gives you deeper protection. It integrates with the web application firewall, and it learns your specific traffic patterns. It knows a Black Friday sale from an attack.
Right.
But the real value, and the notes are specific on this, is the Shield response team.
Actual humans.
Correct. 24/7 access to DDoS experts who can write custom rules in real time. And there's a financial guarantee. If a massive DDoS attack spikes your bill, Shield Advanced absorbs those costs.
Oh, wow. So it's basically insurance.
Exactly. For an enterprise, that alone is worth the subscription. You don't want to be fighting a hacker and your CFO at the same time.
So Shield is the bouncer stopping the mob at the door.
Uh-huh.
Then Guard Duty is, what, the undercover cop?
That's a great way to put it. Guard Duty is intelligent threat detection. It doesn't sit in line blocking traffic. It sits on the side watching those logs we talked about, CloudTrail, VPC flow logs, DNS logs.
And it uses machine learning.
Right. It builds a baseline of what normal looks like for your account. You know, Dave usually logs in from New York between 9 and 5. If Dave's credentials suddenly log in from a server in another hemisphere at 3 a.m.
Guard Duty flags it.
Immediately.
The notes list some scary specific use cases here. Compromised credentials, malware, crypto mining.
Crypto mining is a fascinating one. It's a very common cloud threat. Attackers often don't even want your data. They just want your compute power. They break in, spin up thousands of servers to mine Bitcoin, and leave you with the bill.
And Guard Duty recognizes that pattern of usage.
Instantly. And because it's integrated with Security Hub, that alert goes straight to the dashboard. It connects the dots.
Okay, so that's external attacks. But what about internal rot? Software vulnerabilities, bugs. The notes bring up Amazon Inspector. How is this different from Guard Duty?
Think of it this way. Guard Duty watches for behavior, someone doing something bad right now. Inspector looks for vulnerabilities, a hole in your software that could let someone do something bad later.
It's a vulnerability management service. It scans the workloads.
It scans EC2 instances, but significantly, the notes mention it also covers containers and Lambda functions. That's critical. If you only scan your servers, you're missing half your infrastructure these days.
The part I found interesting here is the automation. It says it can auto-detect when vulnerabilities are fixed.
And it integrates into CI/CD pipelines. This is the whole concept of shifting left.
Just shifting left.
Instead of waiting until the app is in production to check for security holes, Inspector can check the code while the developers are still building it. If it finds a high-risk vulnerability, it can stop the deployment automatically.
So it prevents the hole from ever making it into the wild.
Exactly. It gives you a risk score, tells you what to patch first. It's proactive hygiene.
All right, let's talk about the vault. Encryption. The ultimate fallback. The notes throw a lot of acronyms at us here. KMS, HSM, SSE. It gets a little dense.
Let's simplify.
Yeah.
The core concept is keys. You lock the data, you need a key to unlock it. The main service here is AWS KMS Key Management Service.
This is the fully managed one.
Think of KMS like a valet service for your keys. AWS builds the secure storage, they handle the hardware, they make sure it's compliant. You just tell the valet who can use the key. You control the permissions. AWS controls the physical security of the key itself.
But the notes also mention Cloud HSM Hardware Security Module.
That's for when you can't trust the valet. Maybe you have strict regulations that say you and only you can ever have access to the key material. Cloud HSM gives you a dedicated physical device in the AWS cloud. AWS can't see your keys, period.
And XKS, External Key Store.
That's for when you want to keep the keys in your own data center but use them to encrypt data in AWS. It's the hybrid option.
Okay, now for the data itself, there's this soup of SSE types. SSE S3, SSE KMS, SEC.
It's simpler than it looks. SSE is server-side encryption. The encryption happens on AWS's servers. SSE S3 means Amazon manages the key for you. It's the easy button.
Okay, so basic protection.
Right. SSE KMS means you use that valet service we talked about, KMS. You get more control and an audit trail of who used the key.
And SSEC.
C is for customer. You have the key on your laptop, you send it with the data, AWS uses it to encrypt, and then AWS throws away the key.
So if you lose your key.
The data's gone forever. High stakes, high security.
And there's also client-side encryption.
That's the tinfoil hat approach, and I say that as a compliment. You encrypt the data on your machine before it even touches the network. AWS only ever sees scrambled garbage.
I want to touch on Secrets Manager before we move on. The notes mention rotating secrets. This feels like a solution to a very common developer sin.
Oh, the sin of hard-coding passwords, putting database passwords right in the source code. If that code leaked or an employee left, it was a nightmare to change that password.
So Secrets Manager is like a safe deposit box.
A smart one. Your app calls Secrets Manager to get the password when it needs it, but the killer feature is rotation. Secrets Manager can automatically change the database password every 30 days without a human ever lifting a finger.
That eliminates the "I forgot to change the password when Bob quit" problem.
Completely. And quickly, ACM, AWS Certificate Manager, handles the SSL TLS certificates, the little padlock in the browser. Same benefit. It auto-renews them. No more expired certificate warnings that scare away your customers.
Which brings us to our final section. Governance, or as I like to call it, proving you follow the rules so you don't get fined.
It's the least sexy part of security, but probably the most important for staying in business.
The notes highlight AWS Audit Manager.
If you've ever been through an audit, you know it's weeks of taking screenshots of settings. Show me your firewall rules from last Tuesday. It's just grueling.
And Audit Manager automates that.
It maps your AWS usage to pre-built frameworks like HIPAA or PCI. It continuously collects evidence. So when the auditor walks in, you just generate a report. Audit-ready reports with minimal manual intervention.
That phrase seems to be the theme of this whole deep dive. And this circles back to AWS config, doesn't it? We talked about visibility, but the notes mention automated remediation.
This is the self-healing part. This is the immune system we started with.
Give me an example of how that works. That sounds like sci-fi.
You set a rule in config. Let's say no S3 buckets should ever be public. The moment someone, maybe a junior dev, accidentally makes a bucket public, config detects it. But instead of just sending an email, it can trigger a function to automatically switch that bucket back to private.
So the system fixes the vulnerability before an attacker can even find it.
In seconds, not hours or days.
That is powerful. So let's step back. We've covered a lot of ground.
We have.
We started with Visibility Cloud Trail and CloudWatch as the nervous system. We moved to Active Defense Shield and Guard Duty as the bouncer and the detective. We locked the data in the vault with KMS and Secrets Manager. And we used governance tools like Audit Manager and Config to keep the system healthy.
And the glue holding it all together is just automation.
It really is. The shift isn't just about better locks. It is all about speed.
Exactly. The notes emphasize end-to-end security. You can't just buy one tool and forget it. You have to architect a solution using all these building blocks. It transforms security from a roadblock into an enabler.
Which leads me to a final thought for you. We're entering an era where attacks are driven by AI. We have automated bots scanning for vulnerabilities 24/7. Speed is the only thing that matters.
Human reaction time is simply too slow now. You can't manually fight an automated attack.
Exactly. So here is the question to mull over. If the attacks are automated, can a business actually survive without an automated defense? Or is the idea of a security engineer manually responding to alerts, is that just becoming a relic of the past?
I think the notes make the answer pretty clear. Automation isn't a luxury anymore, it's a requirement.
Something to think about before you deploy your next server. Thanks for diving in with us. Stay curious and stay secure.